Hello everyone, welcome to this video on lathe machine tool. In this video, basics of lathe machine is explained along with some basic operations. To produce a product, several manufacturing operations are required to carry out on a material. The process includes many operations like casting, cutting, joining, polishing, assembling, etc. Metal cutting is one of the important operations which may be carried out either manually by using hand tools or by using metal cutting machines. When machines perform the metal cutting operations by the cutting tools mounted on them, they are called machine tools. A machine tool may be defined as a power-driven machine which accomplishes the cutting or machining operations on it. The fundamental machine tools that are used for the machining operations are lathe, drilling machine, tapping machine, planing machine, milling machine, grinding machine, etc. Lathe is a machine tool used to produce circular objects. Lathes are classified as engine or center lathe, speed lathe, turret lathe, capstan lathe, automatic lathe, computer numerically controlled CNC lathe, etc. The most commonly used general purpose lathe is engine lathe or center lathe. The term engine is used because lathe machine was initially driven by engines for producing the circular objects by manual operations. Nowadays, instead of engines, motors are used. A lathe works on the principle that a cutting tool can remove material in the form of chips from the rotating workpiece to produce circular objects. Lathe holds the workpiece rigidly and rotates them at very high speed, while a cutting tool is moved against it. Workpiece is held rigidly by one of the work holding devices known as chuck, and the tool is held by tool holder. Normally, a V-shaped single point cutting tool held against the workpiece opposite to its direction of rotation. Tool is moved parallel to the axis of the lathe called lathe center axis to produce circular surfaces. The material of the tool must be harder and stronger than the material of the workpiece, or else material will be removed from the tool surface, making it useless. High-speed steel or carbide is used as tool material to machine most of the workpiece materials. Major parts of the lathe includes bed, main drive, headstock, cone pulley and back gear mechanisms, tilt stock, lead screw and feed rod, carriage assembly, feed gearbox, etc. Here we will discuss about some of the important major parts of lathe one by one. Lathe bed is the foundation part of a lathe and supports all its other parts. It is made by using casting process. The top of the bed is polished precisely with machined guideways. There will be two sets of guideways, namely outer ways and inner ways. The headstock and the tailstock are mounted on the inner ways, which keep them perfectly aligned with each other. The outer ways guide the movement of the carriage assembly longitudinally or parallel to the lathe center axis. An electric motor mounted on the left leg of the lathe in contact with the belt drive from the motor to the spindle that forms the main drive of the lathe. Headstock is rigidly fixed on the extreme left side of the lathe, which comprises of gearbox and cone pulley arrangement. The spindle projects out from the headstock to which a chuck is mounted. Chuck is a work holder which has 3 to 4 jaws to hold the workpiece at the center. Jaws can move in and out by using chuck key. Instead of chuck, live centers can be mounted on the spindle if the diameter of the workpiece is too large to mount on chucks. Motor speed cannot be varied, but different machining operations need different speeds, and hence a speed varying mechanism like cone pulley or back gear must be used. Cone pulley drive is used to vary the speed of the spindle. It is an open belt drive with stepped pulley arrangement. Various spindle speeds can be obtained by shifting the belt on the different steps of the cone pulley. Spindle speed can be further varied using a back gear arrangement. In back gear arrangement, spur gears with simple and compound gear train are used to vary the speed. Tailstock is a movable part of the lathe that carries a dead center in it. The main use of tailstock is to support the free end of the long workpiece. It is also used to hold the tools like twist drills for making holes, tabs for making internal threads, etc. Tailstock can be moved on bedways and locked in any desired position using locking nut or lever. The carriage assembly supports the tool and rides over the bedways longitudinally between the headstock and tailstock. Longitudinal movement is parallel to the center line of the lathe. Carriage assembly is composed of 5 main parts, namely saddle, cross slide, compound rest, apron and tool post. Saddle is an H-shaped casting that slides over the outer set of the guideways and serves as the base for cross slide. Cross slide is mounted on the saddle and enables the movement of the cutting tool laterally across the lathe by means of cross feed hand wheel. This cross movement is perpendicular to the longitudinal movement. Compound rest is mounted on the top of the cross slide and supports the tool post. It can be swiveled to any angle on the horizontal plane to facilitate the taper turning and thread turning operations. It is moved manually by the compound rest feed handle independent of lathe cross feed. Apron is mounted at the front of the saddle beneath it and houses the carriage and the cross slide mechanisms. The apron hand wheel moves the carriage assembly manually by means of rack and pinion gears. Tool post is mounted on the compound rest. The tool post clamps the tool holder in proper position for machining operations. Lead screw is a screw rod which runs longitudinally in front of the lathe bed. Lead screw rotates by the help of the same motor which is used to rotate the spindle. Lead screw rotation moves the carriage automatically in longitudinal direction. The feed rod is a stationary rod mounted in front of the lathe bed and facilitates the longitudinal movement of the carriage. The feed gearbox is mounted on the left side of the lathe bed and below the headstock, which helps the rotation of the feed rod and screw rod for the carriage automatic movement. It houses the gears mechanism that transmit various speed ratios for the headstock spindle to either rotate lead screw or the feed rod. Lathe specifications include 5 important points which I'll explain here. Maximum diameter of the workpiece that can be revolved over the lathe bed is called as swing of the lathe is the first specification. General purpose lathe will have limitation of up to 30 cm diameter workpiece, whereas industrial lathe will be in the larger size with more swing value. That means more diameter workpiece can be mounted and can be machined. Second specification is the maximum length of the workpiece that can be mounted between the centers. This length depends on the distance between the headstock and the tailstock. Third specification is overall length of the bed or size of the lathe. Fourth specification is horsepower of the machine. It depends on the type of motor or its power consumption. And the last specification is speed range and number of speeds of high-speed spindle. This also depends on the type of motor used and the number of mechanisms used in order to vary the speed. Single point cutting tool will have V shape and the nose of the cutting tool will be in point contact with the workpiece. The cutting tool is provided with the clearance on the top, underside and at the side of the pieces. Figure shows the general purpose single point lathe cutting tool. The face is the top of the tool and is the surface over which chip glides over and passes away from the workpiece. The cutting edge is sharp part of the tool that does the actual cutting of the metal. The flank is the taper surface directly below the cutting edge. The nose is the tip of the tool bit formed by the side and the end of the edges. The base is the bottom surface of the tool. A nose radius of 0.8 mm works well with most of the operations. Almost all the basic machining operations can be performed on a lathe. Some of the very important and generally performed lathe operations are plane turning, facing, knurling, drilling, thread cutting, and taper turning. Here I will explain about all these operations one by one briefly. In plane turning operation, workpiece is supported in between the two centers, namely live and dead centers, and allowed to rotate. A single point cutting tool is fed perpendicular to the axis of the workpiece to a known predetermined depth of cut, and is then moved parallel to the axis of the workpiece from right to left side. This operation will cut the material which comes out in the form of either continuous or discontinuous chip. In this machining operation, the workpiece is reduced to the cylindrical section of required diameter. Facing is an operation used to generate either flat surface or shoulders at the end of the workpiece. In facing operation, the direction of feed given is perpendicular to the axis of the lathe. The workpiece is held in the chuck and allowed to rotate. The facing tool, which is a single point cutting tool, is fed either from outer edge of the workpiece progressing towards center or vice versa. Knurling is an operation performed on a lathe to generate serrated surfaces on the workpieces by using a special tool called as knurling tool, which impresses its pattern on the workpiece. It consists of one upper roller and one lower roller on which the desired impression pattern can be seen. The impression pattern can be straight lines, diamond pattern, or any other. The serrated surface on the workpiece formed by knurling is used for the application where grip is required to hold the part. Usually, a low speed of 60 to 80 rpm is prescribed for knurling operation. Drilling is the operation of producing a cylindrical hole in the workpiece. The tailstock of a lathe can be used for drilling with the aid of drill chuck attachment. The drill chuck has a taper shaft which can be pushed into the hole of the tailstock, locking it in position. The workpiece is held in the chuck and allowed to rotate. A countersink type of drill bit is used instead of normal drill bit used in normal drilling machines. Drill bit is aligned axially and introduced into the workpiece manually till a countersink hole is formed. This hole on either side of the workpiece helps in holding in between live and dead centers. In order to create large diameter hole, a large size twist drill bit is used after drilling countersink hole. A thread is a helical ridge formed on a cylindrical or conical rod. It is cut on a workpiece when the tool is moved longitudinally with uniform linear motion while the workpiece is rotating with uniform speed. A proper gear ratio must be maintained between the spindle on which a workpiece is mounted and the lead screw, which enables the tool move longitudinally. The screw thread of the required pitch can be cut after arranging the gears. A single point cutting tool employed to cut V threads. When square threads are to be cut, square end tool will be used. Taper turning is an operation on a lathe to produce conical surface on the workpieces. It is accomplished either by swiveling compound rest or by offsetting the tailstock. Taper turning by swiveling the compound tool rest is a method of taper turning which is more suitable for workpieces which require steep taper for short lengths. For taper turning, the compound tool rest is moved linearly at an angle so that the cutting tool produces the taper surface on the workpiece. Taper turning by offsetting the tailstock is also known as set over tailstock method. It is the most commonly used method when the workpiece length is more. When the tailstock center is set out of alignment, the workpiece gets taper turned because its axis will be inclined at an angle with the longitudinal moment of the tool. The carriage is to be moved parallel to the lathe center to cut the taper. This method is more suitable for jobs having less taper as it is limited by the size of the tailstock, and hence this method is best suited for long workpieces having less taper.